Hi, Algebra students. Today we are going to talk about sections 212 through 214. So have out your notes so that we can get started with that. I'm trying to share my .cam with you guys. It never wants to cooperate the first time. So let's try it again here. Okay, there we go. Okay, so we're going to talk about 212 through 214, which is about slope, a measure of steepness. So as we go through this, what we want to try to answer is what makes a line steeper, what makes lines less steep, how is growth related to steepness, where's the starting value on a line, how can you tell if a slope is positive or negative, and what does the line with a slope of 0 look like? So by the time we're done with this, we should have answered all of these questions. We're going to start with 2-1. So this actually comes from the first section that we had talked about. So we're just going to go through this kind of as a refresher. So first, what do you notice about the pattern? So there are lots of different ways to see this pattern. The way I saw the pattern was I noticed that there seemed to be kind of 4 in the middle here each time. And then I saw it growing on the sides. Now, if you saw it differently, that is totally fine. There's a question later on in this problem that asks us to label how we see it growing with color, and I'm kind of doing that right now. Okay, so I see here, I see 1, and on the left, I see here 2, and then here, I see 3. And I'm noticing that that relates directly to what the figure number is. And then over on this side, I see 2, and then over here, I see 4, and over here, I see 6, and I'm noticing that's twice what the figure number is, right? So it's the figure number times 2. Now, again, you may have seen it differently. Maybe you notice they all start with 6 across, and this doesn't have anything, and then this is a 1 here, and then a 2 here, and then this has a 1, and this has 3, and this has 5. Okay, there are different ways to see it. That's how I saw the pattern. Okay, so now it's asking me to sketch the next figure in the sequence, so asking me to sketch figure 4. Now, using what I saw, I would say, okay, well, I've got 4 blocks in the middle. And if it's figure 4, then over here, I should have the figure number worth of blocks. So I should have 4 blocks. And over here, I should have twice that, right? If here were 4, then over here, I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's how I see it. If you saw it differently, then you should draw yours based off of that sketch. All right, now it says figure 0 is the figure that comes before figure 1. What would figure 0 look like? Okay, well, in all of them, they have the 4 in the middle. So I still have 4 in the middle. And then, okay, well, on the left is whatever the figure number is, which is nothing. So I wouldn't have anything on the left. And then this is double whatever the figure number is in my way that I saw it. So that would be nothing. So figure 0 would just be those 4 blocks across. All right, so now, by how much is each figure growing? And that says use color to show the growth. Okay, so I used a little color here before. I could also do that, I guess, a little bit differently. Because I could say, well, in this one, I started with 4, and then I have those that were added on. Okay, so then if I sketch that same little bit in each of them, right, this is what was added from the first figure. And then in the second figure, I added on kind of that same shape. So how many are being added on each time? By how much is it growing? Right, and then the third one, it's like I had this and I had this. Did you see how each figure is increasing by 3? So you're increasing by 3 tiles each time. Now you might have also seen that if you counted how many tiles there were. So this one has 7, you count all these, you have 10, you count all these, you have 13. So you might have noticed it that way. Oh, it's going up 3, it's going up 3. So now the next part is asking, what would figure 100 look like? And how could you determine how many tiles are in figure 100? So I'm going to use my same idea. I'm not going to draw all the tiles, so that would take forever, right? But I have this idea of I'm starting with 4 in the middle, and then on this side, I did not draw this to scale very well. My 4 is going to end up bigger than my 100. But I know on this side, I have 100, whatever the figure number is. And then on this side, I have double whatever my figure number is. I'm really not doing a good job of drawing the scale right now, which would be 200. And so if I wanted to know how many tiles total there were, I could add these three numbers up and get 304. And so now what we want to do is write an equation that relates the figure number x to the number of tiles y. So my total number of tiles y is, I have my 4 in the middle, plus if my figure number is x, over here I have x tiles, and over here I have 2 times however much my figure number was, so I have 2 times x, which I could rewrite as y equals 3x plus 4. So this 3, notice, is the amount of tiles you're growing by, or we call that also our slope. And then this, if you notice, how many tiles did I start with? I started with 4. Okay, so this is your starting value. So we're going to use those ideas of how much we're growing by and what was our starting value as we get into this next set of examples. Okay, so for number 13, describe how the pattern grows and how many tiles are in figure 0. X represents, I should say Y, represents the number of tiles in the figure. Write an equation that relates the figure number X to the number of tiles Y. Decide if the graph represents a function. If so, write it in function notation. If not, explain why not. Okay, so there are a few things going on in there. So first, let's just decide how much is this growing by. So this, remember, is the figure number. This is the number of tiles. Okay, so if I think of this is 0, figure 0, if I go from figure 0 to figure 1, so notice the scale here, right? This is, I went up by 1 figure. How many tiles did I go up by? So to see how many I went up by, let's see, here I went up by, now this is going by 1. So I went up 1, 2, 3, 4. Okay, so for every 1 figure number, I increase by 4 tiles. And so when it says to describe how it's growing, I could say it increases by 4 tiles for each figure number. Okay, now when I go to write my equation, just like the last one we did, it's going to be y equals, now however much I'm growing by, so I'm growing by 4, it's 4x plus how many tiles did I start with? So let's look at 0, figure 0, I had 3 tiles, so plus 3. So now it's asking, is this a function? We talked about this in chapter 1. Is this a function? So that means for every figure number, is there exactly one possible number of tiles? If there's only one possible number of tiles, then it's a function. If there's more than one possible number of tiles, then it's not a function. Well, that doesn't make sense for there to be more than one number of tiles for each figure number. So this is a function. And then it says to write your equation using function notation. So instead of writing y equals 4x plus 3, remember that function notation, we would say f of x equals 4x plus 3. So we have some rule f where our independent variable is x, and this is how you find the total number. Okay, so let's move on to part B. So when we look at part B, they already say for 1 increase in figure number, the number of tiles increases by 12. So I can see that right by looking at it, right? So it increases by 12 tiles for each figure number. Okay, so then the equation would just be y equals 12x plus, right? That whatever you're multiplying by the x, that's the amount you increase by, plus how many did I start with? Well, at figure 0, I had 9 tiles, so plus 9. Right, and then again, is this a function? Remember, whenever you have a line that's not vertical, it is a function, right? It would pass, we talked about that idea of a vertical line test. A vertical line would only cross at one point, and that idea that means for every figure number, there's only one possible number of tiles. So this is a function, right? If you look at these are all functions, and we could write this as f of x equals 12x plus 9. All right, so then for our last one, I want to see how much is it growing by. So if I start with figure 0, and then I go over 1 figure number, so for every increase in 1 figure number, I'm going up 1 total number of tiles. Okay, so it increases by 1 tile for each figure number. So then our equation would be y equals 1x, or just x, plus, how many did I start with? 1, 2, 3. Okay, we talked about how this would be a function, and then we could just write this as f of x equals x plus 3. All right, so let's look at this next one. How is this line growing? In other words, how many tiles are added each time the figure number is increased by 1? Okay, well, looking at this one, they don't tell me how much, I mean, even here, it's not lined up. Well, maybe I could see from 4 to 5, how much is it going up by, but I can't tell very well with this scale. But they tell me for every 3 figure numbers, it increases by 27. So think about that. If every 3 figure numbers it increases by 27, how much does it increase for one figure number? And so I could just divide 27 by 3 and say 9, right? So it's increasing by 9 tiles for each figure number. Okay, so now this idea with these triangles that I've drawn that we looked at in each of those examples 13 and 14, the triangles are called slope triangles. Okay, slope is the measure of steepness of a line. It's the ratio, so ratio means a fraction, comparing the vertical distance to the horizontal distance of a slope triangle. The vertical part of the triangle is called, it says triangle Y, which we're going to read as change in Y. While the horizontal part of the triangle, it's got this little triangle and then X, where it is change in X. Now that symbol, that's the Greek letter delta. Okay, so a lot of times you'll hear me refer to these as delta Y and delta X. So that Greek letter delta is often used to represent difference or change. Okay, so that's why we use that symbol. It's just shorthand. Instead of saying change in Y, I can just write delta Y. Okay, so looking at this line, it's asking what is the vertical distance, or the delta Y, for this slope triangle. And so here's my delta Y. What is this vertical distance from here to here? Is 1, it's 2 units. And then what is the horizontal distance, or delta X, or change in X, for the slope triangle? So from here to here, 1, 2, 3, 4. Okay, now, when we were talking about the tile patterns, we were talking about, well, how much did it increase by for just one single figure number? So now part C is asking, draw smaller slope triangles for this line with a delta X, or a change in X, of 1. Use one of these triangles to find the slope of this line. Okay, so I could draw this slope triangle here. So I could draw, here's one figure number, and then I could draw this little triangle here. So I want to draw slope triangles where the change is 1. So I could draw another one, let's say here, from this point, and then go 1 unit, and then I have this little slope triangle. Okay, and I could draw lots of different ones. So I could start here and go 1 unit, and I could draw this little slope triangle. I could do that all along here. Okay, so what it's asking us to do now is find the slope. So if I wanted to find the slope, so for every one figure number, right, my change is, how much is it increasing by? It's increasing by, it looks like half. Okay, so I would say that my slope is 1/2. That's what I was doing before. How much is it increasing for every one figure number? So for every one, it's increasing by half. So my slope is 1/2. So now the question is, how could I have used these change in Y and change in X that I had up here to get to the slope without having to redraw it where I go over 1, and it's kind of not as easy because it's not a full unit. So what could I do to the 2 and the 4 to have it equivalent to 1/2? What I could do is I could divide them, right? 2 over 4 is equal to 1/2. And so what I could do is I could say, in general, to find my slope, what I'm doing is I'm dividing the change in Y by the change in X. And that's in general what we're going to do to calculate steepness or slope. So now if I want the equation for the line, I would say Y equals 1/2 X, right? The amount I'm increasing by for each one times X, plus what's my starting value? How many tiles did I start with? So at figure 0, if you imagine these to be like our figures and our tiles, I started with 2. And so that's how I could get my equation. All right, so now let's move on to number 25, 2-25. One way to think about slope or growth triangles is stairs on steps of a line. So I have all these different lines. So I want you to picture yourself climbing or descending the stairs from left to right on each of these lines. So we're always going to start from left to right. Of A, B, and C, which do you think is the steepest? Which do you think is the least steep? So if I look at A, B, and C, so when I look at these, I think B is the steepest. It just seems to increase by more for every 1 unit than the rest. And to me, C seems the least steep. It seems like it increases by the smallest amount for each one. Like if I was thinking of these as figure numbers. So I'm going to say C. Right now, it says examine line D. What direction is it traveling from left to right? And what number should be used for delta Y to represent that direction? So as I look at line D from left to right, it's different from A, B, and C because it's heading downward. Okay, so line D is decreasing. And when we talk about decreasing, we always think left to right. And so if I wanted to think about what number I could use for delta Y, so like if I think right here, that change in Y, it's going down 2. So I would use -2 for my delta Y. To show it's going down, I'm going to use a negative. Okay, so now it says label a slope triangle on each line, then find the slope of each line. Okay, so really the triangles are already drawn for you. So we want to figure out what's a change in Y over a change in X. So for line A, and if I'm thinking change in Y over change in X, I do want to think of it as doing the change in Y first and then change in X. So I'm going to pick any of these triangles. And what I'm doing is I'm going down. So I'm going to use a -1 to indicate that I'm going down. And then I'm going to the left. To show that I'm going to the left, I'm going to use a negative number. I'm going to the left 1. And so my slope for line A would be 1. You could draw more than one slope triangle than what's given. You could also think of it as going up 1 and over 1. And that would also give you 1. Okay, for line B. So I already have some drawn in here. So I might just use these. So here I'm going down 1, 2, 3. So that's -3. And then I'm going to the left 1. So -1. So -3 over -1, which is 3. Okay, for C. For C, let's see, pick one of these triangles. To get from one point to another, I'm going down 1. So -1. And then I'm going to the left 2. So -1/2. So -1 over -1/2 or 1/2. Okay, and then for line D, okay, well, we already talked about for line D how we would say that we're going down 2. So we're going down 2. So my delta Y is -2. And then I'm going 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the right. So if I'm going to the right 4, so -2 over 4, it would be -1/2. All right, so now part D, how does the slope relate to the steepness of the graph? Okay, so some people, when they answer that question, they want to say something like the higher the slope, the bigger the number of the slope, the steeper the graph is. And that's kind of true, but what about C and D? Notice that these slopes are opposites. If they're opposites, that means they have the same steepness, but the positive and negative are just telling me that one's going up from left to right and one's going down from left to right. Okay, so I don't want to just say the bigger the number, the steeper it is, because what if I had a line, like what if I had line B, but let's say it was going down? That I would say is steeper than, let's say, C or D or even A. So the way we kind of talk about that is the greater, it's like we want to think about it without regard to what the sign is. So we're going to think of it as the absolute value. And a lot of times we're going to use M to represent slope. So the greater the absolute value of the slope is, the steeper the line. Okay. All right. So now take a look at number 26. So again, a lot of similar questions. So which is the steepest, which is steeper, B or C? Draw slope triangles for each and then calculate your slopes. So looking at these, I would say, I don't know, the steepest line seems to be A. Okay, now which is steeper, B or C? So here's B. Pay attention, the labels are kind of tricky. This is C right here. This is the D. Okay, which is steeper, B or C? So it seems like B is steeper. Then it says draw slope triangles for each line using the highlighted points. Label your delta Y and delta X. And then once you have your slope triangles, you're going to match each line with its slope using this list below. Okay, so here's all the possible answers. Note that there are more slopes than lines. Okay, so for line A, and it says use the slopes that are, or the points that are there, and you can use any point you want. It's up to you how you want to draw your slope triangle. So I could pick, let's say, this point and this point, and I would say, okay, my change in Y is 2, my change in X is 1. So for A, my slope is 2 over 1, which is 2. So that's A. All right, so then for B, so here's B. I can pick any 2 points. So I can pick these 2 points. Now you can go, and it doesn't matter. I can start here and go up to this one, or I could start here and go down. Now, if I start here and go down, it's down 1, 2, 3, so -3, and then it's to the left 2, so -2. So you could think of it that way if you want. So you could think of it as -3 over -2, which is the same as 3 over 2, which is right here. Okay, so then for line C, which is this one, I'm going to pick any 2 points. I might pick down here just so that I'm out of the way of where I picked before. If I can, I like to go up and over. I don't know, it seems easier to me, but you can do it how you want. So here I'm going to go up, and I'm going to go up 2, and then I'm going to go over 1, 2, 3. So for C, it's 2 over 3. It didn't come out very well. 2 over 3, which is here. C. Okay, so remember they had asked about B and C and which was bigger. They're reciprocals of each other, you might notice, but 3/2 is 1.5 and 2/3 is about 0.6 repeating. So B was the bigger of the two. All right, and then for D, so D, which is this one here, let's see here. I'm going to get from this point to this point. So you can pick any 2 points you want. So I'm going down 1, and then I'm going over 1, 2, 3, 4, 5. Okay, so for D, my slope is -1/5. All right, and then I've got one more. I've got line E. Okay, so for line E is a little different, right? It's a horizontal line. So if I pick, let's say, this point and this point, and I think to get from this point to this point, what's my change in Y? Well, I don't go up or down at all. So my change in Y is 0 over whatever, 1, 2, 3, 4, 5, which is 0. Okay, so horizontal lines have slopes of 0. Horizontal lines have slopes of 0. Okay, so that's something new that we haven't mentioned yet. Okay, so this idea of drawing slope triangles is going to be very helpful as we move forward. All right, so then last one, number 29. What happens to the slope when the slope triangles are different sizes? So if we look at this line below here, 3 different slope triangles are drawn. So you're asked to find the slope using each of the slope triangles, and then what do you notice? Okay, so for A, let's see, A, I'm going up 1, and then I'm going over 2, so 1/2. Okay, so B, here I'm going down 3, so -3, and then I'm going back 6, so -6. So -3 over -6. All right, and then C, I'm going down -2, and I'm going back 4, so -4. So -2 over -4. Okay, what do you notice about those 3 values? You should notice that they're all equivalent, right? So they're equivalent. So it says triangle A was drawn above the line. Does that, the fact that it was above, below, instead of below the line, does that affect the slope? It doesn't, right? They all end up being the same. And I could have, for that one, if I wanted to, I could have drawn it below. I could have chosen to go down 1 and go back 2, and I would get the same slope, okay? So it doesn't matter. They are equivalent. All right, so then you're asked to draw another slope triangle now so that delta x is 1. So the change in x is 1. That's sort of like we were doing with the tile patterns. What is the height of delta y in this new slope? You might even be able to kind of figure out what it would be just based off of what we've talked about, because no matter what 2 points you pick on the line, the slope is going to be the same. Okay, so if I wanted to pick a delta x of 1, I'm just going to start from figure 0 and go to figure like 1. I'm going to think of it as figures. And then I go up to the line and draw that triangle. Well, what does it look like that delta y is? Half, which is what it should be, right? That's what they're all equivalent to. Okay, so people will ask, does it matter which 2 points on the line I pick to get my slope? It doesn't. They're all equivalent, right? It's the same line in every single case. So in every case, you're finding the same, you'll find the same steepness. So kind of bring everything together that we talked about just now. Slope is the change in y divided by the change in x. And we can use this shorthand of delta y over delta x. Okay, if you have a positive slope, that means that your line is increasing. If you have a negative slope, that means your line is decreasing. Okay, making note of this is a good idea, right? Just to keep track of if you're giving an accurate answer when you're describing slope. So you should, once you figure out your value, you should look and say, okay, it's increasing. Did I say my slope was a positive number, or it's decreasing? Did I make sure to think of it as a negative number? So this is something really important to think about. And then if we have a slope of 0, that means we have a horizontal line. Okay, so that takes care of our discussion of slope and in general, just talking about the steepness of a line. Take care, algebra students.